Hello and welcome to the first chemistry video made by MUNSCI. This course will follow the IB curriculum, and along this course I will also be providing information that will help give a clearer understanding of chemistry. I would like to start off this course with a brief introduction on the particulate nature of matter, since this will provide a good basis to start off stoichiometry, topics 1.2 and 1.3 in the IB syllabus, and this will also help in other topics coming up. Let us begin with the definition of matter. Matter is anything that has mass, occupies space, and is made up of particles such as atoms, molecules, or ions. Now, matter can be present in three states, also known as forms. There is the solid state, the liquid state, and the gas state. Now, these states of matter are all dependent on the temperature and pressure placed upon it. Now, let's discuss the first state of matter, the solid state. The intermolecular forces of attraction between the particles in the solid state is extremely high. This causes the particles to be tightly packed, giving it a fixed shape and volume. Now, the kinetic energy in the solid state is fairly low. There is vibration and there's also rotation. However, due to it only being in a fixed state and the lack of space between the particles, it will only stay there and be in a fixed position. Now, let's move on to the liquid state of matter. The intermolecular forces of attraction between the particles in a liquid is lower than that of a solid. This means that the particles are loosely packed and they have a fixed volume but no fixed shape, as the shape of the liquid depends on the container it is placed in. The particles in a liquid can rotate, vibrate, and slide due to the presence of a greater intermolecular space between the particles. Now let's move on to the final state of matter. Gas. Particles in the gases are extremely loosely packed, and there is little to no intermolecular forces of attraction between them. This means you do not have any fixed shape or volume. Like liquids, the particles rotate, vibrate, and slide, but with a higher velocity. Let's look at some examples of solid states, liquid states, and gases. Now, a solid state can be seen in, for example, ice, where the particles are extremely tightly packed, as seen in the diagram. As you can see, there's extremely high intermolecular forces, and there's a fixed shape and volume. You can't see it, but there's also going to be vibration and rotation for each individual molecule. The liquid, however, is more loosely packed. As you can see, there's less intermolecular forces of attraction, plus they can vibrate, rotate, and also slide, as you can see between these things. Now finally, gas. You can see that there's extremely low intermolecular forces of attraction. Therefore, extremely spaced out, they're not connected at all, or extremely little connected. The particles are very loosely packed, and there's no fixed shape or volume. They also rotate, vibrate, and slide. Now, let's look at a graph to help symbolize how the states of matter change. So as you can see, the temperature is in degrees Celsius, and then it is in time that goes on as the x-axis. Now we can observe that as there is an increase in temperature, the state of water changes through melting, so here, and then through boiling here. However, as you decrease, so going backwards here, you can notice that condensation occurs over here. So here you can see both boiling if you're increasing in temperature, and you can also see condensation if you're decreasing in temperature. And then over here, you can see freezing if you're decreasing in temperature. So you can see some melting if you're increasing in temperature and freezing if you're decreasing in temperature. Now, note that there is no change in temperature as the process of melting and freezing and the process of boiling and condensation is occurring. This means that the temperature remains constant during the changes of state due to the fact that all molecules are attempting to change the state, and then after that, it starts to increase again. Now, some important terms that you'll come across in your chemistry course is the changes of state, and their names. Essentially, the change from liquid to solid, so this way, is called freezing. The change from solid back to liquid is called melting. A change from gas to liquid is called condensation, and a change from liquid to gas is called boiling. Now, there's also direct changes immediately from solid to gas and gas to solid. From solid to gas is known as sublimation. and the direct change from gas to a solid is known as deposition. Now, matter can be classified into two different types of matter. There is pure substances and mixtures. Pure substances can be defined as a definite and constant chemical composition. Pure substances consist of elements and compounds. Mixtures, on the other hand, can be classified as a combination of two or more pure substances. Let's define what an element is. Elements are made up of atoms, and they all have the same atomic number, whereas in a compound, they're made of a combination of atoms in a fixed ratio. And like I said before, I referred to something called an ion. An ion is essentially an element that contains a charge. A positively charged ion is called a cation, and a negatively charged ion is called an anion. Now, mixtures can be classified into two different types: homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are essentially mixtures with a uniform composition and unchanged chemical properties throughout. Heterogeneous mixtures are mixtures with non-uniform composition. Now let's look at our final concept for today: chemical reactions. A chemical reaction is a reaction between two or more molecules to form a new product. Chemical reactions take place in various ways, depending on the substances in the reaction. Let's look at the different types of chemical reactions that you will go through in the Chemistry HL course or standard level course. You have the displacement reaction. A displacement reaction is essentially a chemical reaction where one reactant replaces the other reactant. Oftentimes, the reactant that is displacing the other reactant is more reactive. This can be seen with zinc and copper sulfate. Zinc will displace the copper since it's more reactive to make zinc sulfate plus copper. This is a displacement reaction. A double displacement reaction is where both reactants displace each other. For example, hydrogen chloride plus sodium hydroxide. This will result in sodium chloride, so NaCl, plus water, H2O. This is a double displacement reaction. The next type of reaction I would like to discuss is the neutralization reaction. A neutralization reaction is a chemical reaction where an acid and a base react to form a salt and water. This can be seen with hydrochloric acid plus sodium hydroxide. This will form sodium chloride, so table salt, plus water, a common neutralization reaction that we can see. The next reaction I would like to discuss is the acid plus metal reaction. An acid plus metal reaction is where an acid and a metal typically forms a salt and a hydrogen. This can be seen with hydrochloric acid plus magnesium. This will give magnesium chloride and hydrogen. Next reaction I would like to discuss is the decomposition reaction. The decomposition reaction is a process in which a chemical species breaks into smaller parts in the reaction. For example, carbonic acid can decompose into water and carbon dioxide. Next, I would like to discuss the precipitation reaction. A precipitation reaction is where an insoluble salt is formed after a reaction of two solutions containing soluble salts. You can see this with magnesium hydroxide plus hydrochloric acid. This will form magnesium chloride and water.